So today we'll be talking about the concept of epistasis. What is epistasis? Epistasis is when two different genes contribute to the same phenotype. It's when an allele at one locus masks/modifies the effects of alleles at another locus. On the other hand, simple Mendelian inheritance is when each gene locus has an independent effect on a single phenotype. Let's see what this looks like. In our normal dihybrid cross with no epistasis, we will have a 9:3 to 3:1 ratio. One of the important things to notice here is how the recessive A alleles have no impact on the B right here. If it did, these all must be the same color. In other words, the big B alleles still have an effect on the phenotype even though the A alleles are recessive. We will be using goldfish to represent an example of single recessive epistasis in regards to color today. Let's take a look at the pathway we're going to use. Here we can see that there are three colors. To move to red, we can see that there's a requirement for the big A allele. To move to the gold, we can see there is a requirement for the big A and B alleles. If we have a small a, it will mask over the big B allele. In other words, it doesn't matter whether we have a big B allele here if the A allele is recessive. Now, applying our epistasis to our dihybrid cross from earlier, we will have the following results. We will have 9 gold, 3 red, and 4 green because again, the small A allele will mask over the big B allele. And this is important because it proves to us how it is different from the regular 9:3 to 3:1 ratio. Here we have the full cross drawn out. Anything with the big A and the big B allele is gold. Anything with the big A and small b is red. And anything with the small A alleles will be green. Here is a different cross with the same epistasis at play. Here we have a goldfish with a heterozygous A gene and a homozygous recessive B gene crossed with a green fish. In this case, we will have 4 gold, 4 red, and 8 green. These are my references.